Welcome, my name is Anita Graser. In this demo paper I want to show you how notebooks can be used to visually analyze large amounts of tracking data. The notebook that I want to present to you today is also available on GitHub, so you can download it and try it yourself afterwards. Let's dive right in. The content of this paper represents a whole protocol for exploring problems that are typically encountered in continuous movement datasets, and they revolve around the issues of missing data, precision, consistency, and accuracy problems. I'm using AIS data provided by the Danish Maritime Authority. In particularly, I've picked 2 different days during the summer 2017 and 2018 for the visualizations. The libraries that are used in this notebook revolve around the pandas data analysis family of tools, and for visualizations we mainly use HoloVis and the Data Shader library, and I will explain further in the individual cells how this is used and why this is so useful in my opinion. There's a lot of attributes in this data. Obviously, since we are working with AIS data, there are the vessel identifiers, the MMSI, there is the spatial information, of course there's a timestamp, and there are multiple other attributes such as the navigation status, the ship type, rate of turn, speed over ground, course over ground. A lot of you will have already noticed there are a lot of zero values, there's a lot of nan values, particularly for the speed over ground. There's a lot of zero values which I've decided to remove from the dataset. And this is very straightforward to do in pandas, so this is basically the filter that is applied for the type of mobile and for the speed over ground. And even after this filter is applied, the 2 days, they contain around 10 million records of data that we will be visualizing in the examples in this dataset. First of all, looking at missing data, obviously we want to assess the spatial and the temporal extent. We want to see whether there are outliers. So we can use the default tools that are available in pandas, so we can access all kinds of statistics for the columns, including obviously the minimum and maximum values for latitude and longitude. If we do that, we might already see that there are a couple of obviously wrong values. For example, for the latitude, the value of -110 is not possible on the Earth, so it absolutely makes sense to look a bit more detail, and that is most obvious approach to doing that is to create a scatter plot of the coordinates, and using the HoloVis libraries we can call hvplot scatter on the data frame that we have created to create a scatter plot of x and y values, and we call data shade. And what this does in the background is the points are rendered on the back end. It is rasterized, and only the rasterized representation of the points is sent to the browser, and this makes it possible to render 10 million points in a browser on a map. If you would try to attempt to do that with, for example, leaflet-based visualizations where you have a vector-based rendering in the browser, this just would not work at all. And with the data shade option and the rasterization in the background, it's fast, it's interactive, and we can really look at where all those 10 million points are located. Since we learned that there are outliers, we can crop those away, we can create a new data frame from the cropped version, which is a bit cleaner. We can also look at the same data using a density map approach that's also well supported in Data Shader and actually the default behavior. So in this visualization now we can see where are the dense routes where many vessels travel, and in which other places do we have only sporadic information. Since we are working with pandas, obviously we can also do all kinds of visualizations on the temporal aspects like timelines. It's very easy to resample and to, for example, count the number of records per 15-minute interval and to plot those in myriad different ways, either in this timelines or in two-dimensional time plots, histograms, which can show us whether there are any reoccurring gaps in the data which could point to issues during the data collection process. In this case, when comparing the 2 days, we obviously see that there are much fewer records in the January dataset, so this might be due to seasonal effects. We can also plot maps side by side, and one of the big advantages of the libraries is that those maps are automatically synced. So when I scroll or pan here, the other map is updated as well. And this is achieved by creating the 2 plots like before, and then we combine them by just adding a plus symbol in between, which is really convenient and straightforward. Not many things you can forget here. And you can combine as many maps as you want. So here's an example with 4 mini plots, and again they are all synced and updated automatically, and these here represent the different times of the day. It's also possible with the density maps, obviously, so we can, for example, explore the difference between nighttime and daytime traffic in the port of Copenhagen if we want to. Similarly, besides the spatio-temporal extent, we might also want to find out if there's any gaps in the attribute data, for example, the ship type information, whether it's available or whether it's lacking in a lot of data sets. So we can split up the data frame into individual data frames that either contain or don't contain this kind of information, and we can look at the spatial distribution of these records. And for example, it shows us that a lot of the records here in the North Atlantic, there is no ship type information available, but for some there is, so maybe we have to dig deeper to find out why it's missing for so many records. Besides those looking at the raw data at the individual records, a second step is obviously to compute segment information, so information for segments between consecutive positions. And there's a couple of calculations that are going on here. They are pre-computed, and then this information can be used, for example, to visualize gaps in trajectories. And a gap here is defined as a segment that is extends a certain minimum distance. So in this case, I say if it's longer than 10 kilometers and shorter than 100 kilometers, then I want to see it on this map. And this reveals an area, for example, here in the west of Denmark and also along the coast of Germany and the Netherlands, where there seem to be a lot of these longer gaps where ships leave the coverage area and then return to it. And this can also be achieved by data shading the paths. So again, here we don't work with complex geometry objects, but we can take advantage of some highly efficiently implemented path objects which data shader can plot rather quickly. So this is not quite as fast as the point density maps, but still it keeps it interactive, and we can work with it much more easily than in a comparable desktop GIS environment, for example. The protocol goes on into other problems besides missing data, for example, precision problems such as coordinate imprecision. You may imagine if the coordinates are rounded to only a few decimals, then you get patterns that are like stair-shaped. And if that's the case in your data set, then those stair shapes would result in particularly high values in the histograms for 90 degrees, 180 degrees, and 270 degrees, and potentially also 45, and all the multiples of 45 degrees. So when we look at this data set, the two biggest spikes are certainly for the 90 degrees, and here around 270 degrees. But we don't have a very strong pronounced patterns that every 45 degrees there would be one of those spikes. So coordinate imprecision doesn't seem to affect this data set too badly. We do have a few cases of timestamp imprecision, and what I mean with that is that we have multiple records of the same user with the same timestamp, potentially at different locations, so the ship appears at the same time in different locations. So this is certainly an issue that we would have to look into. So there is around 10 to the power 4 cases where one ship has two records at the same time, and there's also a few cases with even 3 or 4 records. Other things you can explore with this notebook is, for example, the intervals between consecutive records, so whether there's a regular sampling interval. In our case here, most of the intervals are 10 seconds or shorter, but there are also a couple of intervals which are way longer. Which is to be expected because, again, ships might leave the observed area and enter at a later stage, so it was to be expected that we would have this long-tail distribution. We can also look at it with a spatial perspective, so what is the coordinate change between consecutive records, and in this case we can see a picture that shows us that the coordinate changes are densest in the center at around 0, 0. So this is to be expected. In some data sets, you might actually have like an empty area in the middle if there's a resampling strategy, for example, that says we discard all records if the change is not a certain distance. So this kind of coordinate change plot would be useful to discover resampling strategies like that. You may also find other scatter plots useful, for example, comparing the distance traveled and the speed to find out if there are certain outliers that travel long distances at high speeds, which would indicate that there are maybe vessel types that you did not expect. So in the AIS case, analysts might not expect that there are objects in it that are not actually ships. So all the helicopters and planes that are also search and rescue vehicles and covered by AIS data, they can be, for example, identified by having these long daily distances and high average speeds, and they can be plotted as well to actually find out, yeah, they are flying over land, so this is certainly not a ship. Same thing, if you just filter for long distance travelers, you can find any combination of trips that are affected by outliers that require cleaning, but also, of course, you could find the planes if you hadn't filtered them out yet. The final data preparation step, which is also covered by this notebook, is computing trajectory information. So we aggregate the segments to trajectories. And with this information, we can, of course, look at median speeds. We can look at the total length of the trajectories. We can look at the start time of the trajectories. And we can identify individuals that do not fit the expected distributions. And when we want to look at individual trajectories and explore those into more detail, that's where the moving pandas visualizations come in. For example, here we have one single mover, which actually there are two ships that share the same MSI, and this results in these patterns here. And similarly, we can have a closer look at those trajectories with the individual outliers, or with particularly problematic speed values and a lot of jitter, for example, in the trajectories. So with that, I want to invite you to have a closer look at the notebook and to reach out to me if there's any questions. Thank you.